Everybody, it's a great pleasure to be here with you again. These meetings have always been a lot of fun to attend. I think all of us enjoy the face-to-face conversations on these occasions that we don't have during the intervening periods of 2 years. At any rate, I've got a lot to talk about this morning, and I'll go through these slides pretty quickly. I encourage you to look at the version in the printed proceedings for more detail than I'd be able to give now. So I want to talk about this new version of the program MAP 65 that Alex was just talking about. This is, of course, software for a software-defined radio, and it works explicitly with JT65 signals. So it's made for moon bounce. It's made for digital moon bounce communication using this JT65 protocol. It's a sort of a big brother to the more commonly known program, WSJT, and I'll describe how it differs and the ways in which it is a bigger brother. So it's receiver hardware, but it requires receiver hardware that is going to convert your input band, say the 2-meter band or 432 or 1296, whatever, to baseband, and then the digital signal goes into the computer for all subsequent processing. The software decodes the JT65 signals that it finds within the full bandpass, and the full bandpass is defined to be just a little less than the sample rate, which is 96 kilohertz. So with good filtering before the sampling, you'll get something like 90 kilohertz of total bandwidth. It's made for a dual polarization receiver, so it's a complete dual polarization system, and it maintains phase coherence between the two channels so that by linear combinations of the X and Y channels, perhaps horizontal and vertical, or it may be 45 degrees and 135 degrees if you orient your antennas that way, it's able to give you automatic polarization matching. And it does that independently for each JT65 signal that it finds within the passband. So it matches up each received signal with the polarization. And it's designed for EME at the VHF and UHF bands. It's very effective on all of those of the most popular EME bands. So for those of you who don't do digital EME at all, I'll just say a few words about the JT65 protocol. It always uses timed transmit-receive sequences of 1 minute. It uses a set of compact structured messages for making minimal QSOs. Obviously, this is not a rag-chewing mode. You basically exchange call signs and signal reports and Rogers and perhaps a few words of chit-chat and not much more. The modulation is a highly efficient frequency shift keying system, so we're not using amplitude modulation, not even digital amplitude modulation like CW, on or off. It's FSK that has substantially better performance and for a fixed power level. The keying rate is 2.7 symbols per second, 2.7 baud. That means that over the time interval of the transmission, which is a little less than 60 seconds, it's actually about 47 seconds, you're sending 126 symbols, half of which are used for frequency and time synchronization, and the other half, 63 symbols, are sending the information contained in a code word of the Reed-Solomon code, which in turn depends on exactly 12 6-bit symbols, or 72 total bits of information. It happens at 72 bits, 72 zeros or ones is enough to encode 2 call signs, a signal report, and a Roger, and that sort of thing. Just what you need for a minimal QSO on moon bounce. It works at something like 10 to 15 dB below the limit for CW, so you can do it with smaller stations than you can CW. Currently, I would estimate there are something like 1,000 people using this on moon bounce on 2 meters. And you might wonder how I know that number, and I can say, well, I don't know it, obviously, but I can guess that's probably not far off because I've worked 800 different stations on 2-meter moon bounce using JT65, and I know I haven't worked everybody, and all those are in the last few years. So there's really a lot of activity, beginning to be a lot more on 432 and 1296 as well. By the way, there's good reasons why JT65 is not used much above 1296, and that is because its advantage over the CW threshold of sort of audibility of signals disappears once you start having enough signal broadening caused by libration to be comparable to or greater than the limits of your ear at discerning signals from noise, which is around 25 to 50 hertz, depending on your particular skill with CW. That's the filter limit. And this 2.7 baud is the filter limit for JT65. That's where the 10 dB improvement comes from. It's a much narrower bandwidth in which the signal is detected. So enough of that. Let's just compare JT65, or rather WSJT, to MAP65 briefly. For those of you who are more familiar with the original program, WSJT works with the bandwidth of a single sideband transceiver. So a typical bandwidth of a couple of kilohertz. If you're lucky, you might have a switch on yours like the TS2000 that I use has that gives you an IF bandwidth as much as 5 kilohertz, but that's all you get at one time. So you're looking at a small slice at any one time of the EME subband. WSJT, of course, started out as a program for meteor scatter, and it has a number of other modes in addition to the JT65 mode used on EME. You're basically, when using that program, decoding one signal at a time, the signal that's in the bandpass of your single sideband transceiver. And you're also, of course, receptive to only one polarization, typically a single linear polarization. MAP65, on the other hand, is a broadband software-defined radio. The bandpass is 90 kilohertz. It implements only one of the modes. It's made for EME only, and so it implements only JT65. And instead of decoding just one signal, it decodes anything it finds in the whole passband. And during a good weekend, there'll be dozens of signals in there on 2 meters, and it basically decodes them all and displays them on the screen in a way that you can, that I'll say more about in a minute, that you can use to your best advantage. Finding people calling CQ or somebody that you want to tail end on, somebody you've worked before and would like to say hello to. In a contest, it keeps track of who you've already worked, by the way, so it'll tell you who you need to work still of all the signals that are there. And instead of just receiving one polarization, it's receiving both polarizations, 2 orthogonal polarizations, and it then combines those. Linear combinations of those can produce any angle, so you basically can synthesize reception of any angular polarization being received. That means that on average, you're getting a 3 dB advantage on some signals that you would have been more or less orthogonal to. You're getting much more than that. So you see a lot more signals with a dual polarization system than you do with a single polarization one. It produces a band map of everybody that's on the band ordered in frequency, and that's kind of handy to have, especially during a contest. So here's a block diagram of the system. You've got an X and a Y channel coming in. You need hardware to convert that RF to baseband. The receiver that Alex was just telling you about, his IQ Plus, is a very good example of this. The system was originally built to work with the WSE, weak signal equipment converters built by Leaf SM5BSZ, and it was optimized for those, but it works very well with the IQ Plus and with a number of other receivers that I'll talk about in a few minutes as well. Then after that, everything else here is software. You can use LINRAD or another program known as SDR-Radio as an input unit for MAP65, but you don't have to. You can actually use MAP65 directly now on the output of the baseband converters. Either one of those is possible, and there are various reasons why you might want to do one or the other. I normally use LINRAD in front of my MAP65. And MAP65 has a number of different displays, which I'll talk about in detail one at a time. There's a wide graph that gives you a spectral display, a waterfall display of all the signals in the band. There's one that gives you the astronomical data for tracking the moon or the sun or whatever you're doing. There's a main window in which you actually control the contact that you're making. It displays the signal that in a narrow piece of the band that is focused on the particular place where you're making a contact at present, and you select your transmission message and that sort of thing there. Then there's the band map that gives a list of all the signals that it's received in the last 20 minutes or so, and in order of frequency, so you can see who's on and who they're talking to. And then there's another message that gives all the message traffic between all the other signals, so you can keep track of who's working whom and what they're saying and what stage their contact is in, so you can hop on to the next guy in time to tail end his QSO and so forth. Now, MAP65 has been around since late 2007, so nearly 5 years now, I guess. But the current version, version 2, has a number of new features that were not in earlier versions of the program, so I'll just outline those here. The current version supports both dual polarization and single polarization systems, so you can also use MAP65 very effectively with a single polarization system. You don't get that extra average of 3 dB advantage from the polarization matching, and you won't see as many signals because you won't see the ones that are polarized orthogonally to the one you're receiving. But other than that, it works just the same way. It implements all 3 of the sub-modes of JT65. A is normally used on 6 meters, B is used on 2 meters and 70 centimeters, C is used on 23 centimeters and up. Anyway, those are all present in the current version. It allows you 2 different, slightly different sample rates. 96 kilohertz is used for, for sound card sampling and for the FunCube dongle. Another number, which happens to be 2 megahertz divided by 21, it comes out to this number here, and that's used for the SDR-IQ, a nice little $400-something receiver made by RF Space, and a number of others. The Perseus also gives you that sample rate. You need to have one or the other of those 2 very accurately defined sample rates, or JT65 won't work. For a front-end software, you can use either LINRAD or SDR-Radio, and they're optional. You don't have to use either one. You can go directly into the sound card. And then you need some kind of receiver hardware to convert from your operating band down to baseband. For the computer junkies in here, you might be interested in the fact that the current version of the program is written with a software development kit called QT, which is nice because it is cross-platform. It works so that with one collection of software files, you can compile the program for Windows or for Macintosh or for Linux with essentially no changes. That's very handy. The graphical user interface for the program is written in C++, and this was actually the project on which I learned to program in that language, which I had never done before. So it took me a little learning curve to get up to speed on it. The decoder is still written in my favorite old language, which is always a joke. Okay, a number of different off-the-shelf receivers work with MAP65 very nice. And now here's Alex's very, very nice receiver. Here's the Perseus, single-channel device. Here's a SoftRock, the $50 receiver that you can buy from a guy named Tony Parks in the U.S. This one's put into a box, but it's a very handy receiver. Here's the FunCube dongle, a great little thing to play with for only $150 or something. Here's the SDR-IQ. There are many others as well. I don't have pictures of Leaf's receivers here. I should have them, but I didn't happen to get it in time to put it on the slide. But I use the WSE converters, but I also have used Alex's receiver, and it works very nicely. I've also played with the FunCube dongle. It works great. And if you're running on a low budget, by all means use a SoftRock. They work very nicely and will do this system very well. Here's the just one screenshot of SDR-Radio. This is a very professional looking program. It's made primarily for HF, but actually it works very nicely as a IF system for VHF, UHF, and EME purposes. And it will send its output from SDR-Radio directly into MAP65, which is very handy. And some people will find this program easier to get up to speed with than LINRAD may be. And both are very usable with MAP65. Now, normal operation at my station, if I come in and want to work some moon bounce, I turn on the receiver, I warm up the power amplifier, I start LINRAD and MAP65, 2 programs. In my station, they work on 2 different computers, but that's primarily because LINRAD is running under Linux and MAP65 is running under Windows, but I could do it the opposite way. Both programs can be used on the other operating system, and you can run both programs on one computer. If you do that, it's definitely advisable to have 2 monitors on your computer because there's a lot of real estate on the screen that is used, and if you're always having to move windows around to see the one underneath it, it will be annoying after a while. In my station, it's just a click to track the moon, and I'll show you a little bit more about that in a minute. So that'll start. And with MAP65, if you just, once you're on the moon, call signs will start to appear on the screen if you're on 2 meters. There's enough activity that there's almost always somebody on if the moon is above your horizon. If you double-click on a call sign, somebody that's calling CQ, it will copy the call sign into the appropriate register so that when you hit the transmit button, it'll start to call him. Before doing so, you'd better look at the received polarization angle, and it will figure out which transmission polarization angle you should use. It won't be the same one, by the way, because of the nature of spatial polarization. But once you know what the received polarization is and the location of the other station, which is part of his message, he'll send you his grid locator as part of his message by default on JT65. And then you know what transmit polarization you should use. Most of us who do this have only 2 choices for transmit polarization, 2 orthogonal choices, either 45, 135 typically, or horizontal and vertical. And so MAP65 will tell you which one of those to choose. It's a little bit harder on the transmit side than on the receive side to make a transmit system that will transmit at any arbitrary angle. It can be done, but it's not quite so easy, especially since you're dealing with power at that level rather than just signal. Then you click the auto on button, and your transmit at the top of the next minute will go on, and you'll call the guy. Here's what MAP65 looks like on the screen, a full screen display. This is using now most of the screen of a large modern monitor. Here's the wide graph that shows you the full spectrum. I normally display from 144/100 to 144/160 because almost all the activity is in that subband window. All of the vertical bright stripes here, this one and this mess in here and these over here, those are all birdies. Those are not the interesting signals. The interesting ones are the ones that start and stop on the 1-minute boundaries. The horizontal lines are the 1-minute boundaries. So this is a very slow waterfall. It's moving only 50 pixels or so in a minute. But here are some of the strong signals you can see that at a particular frequency. The lower bunch of panels of strips here is a zoomed in picture around a particular frequency that was chosen, plus or minus 2 kilohertz. So you get a zoomed in picture, and here's a couple of signals that are conversing with one another at this point. Here's the astronomical data window. Here's the band map. You can't see the call signs in it right now, but I'll show you a closer picture of that in a minute. Here's the messages window, which is showing all the messages that other people are sending to each other. And here is the main window in which a QSO will take place. Received messages are displayed here, and the transmitted messages are entered and selected over here. You've got the time and other necessary information for controlling the system is there on the screen as well. So here's the main window again, closer up. The QSO window, as I pointed out, is this big area in here. The transmit messages are selected over there. There's a couple of little thermometer bars over here which show the average signal level coming in on each of the 2 channels. The horizontal and the vertical channel are the 2 colored bars. You normally would set your receiver levels so that those are running around 20 to 30 dB or so. If you turn off the DC going up to your preamps, those bars should fall down to 0, okay? And you want to be sure that that difference is going to be something around 20 dB is normal. Here's the wide graph again, slightly expanded so you can see a little bit more of the signals. And unfortunately, these things never show up well on a screen in a large room like this. Look at the picture, especially the one on the DVD, which has full resolution. And you can easily pick out the signals here, and you'll probably see, 30 or 40 EME signals in there if you've trained your eye to pick out the right ones, as I have. Here's again the wide graph with a detail blown up now with only 144, 115 to 135, about 20 kilohertz is shown here, and you can pick out now the signals very easily. There are a number of them, and here again is the even more greatly expanded version where these 2 people are just finishing a QSO. He's just sent Roger. This guy is probably saying, see you in Cambridge, or something like that. Okay, so here's the band map. Again, the colors never come out very well. I'll show you. I think I have a black and white in a minute that'll show you the call signs better. I just wanted to emphasize that I showed that this particular sequence of call signs in the band map is what showed up at a particular time back in 2006 It was during the ARRL EME contest, so there was plenty of activity on. At the time, I had only a pair of 10-element cross-polarization Yagis. There were about 50 call signs on the screen here, and that was all over a 10-minute interval. So, there's lots of activity, and MAP65 basically decodes everybody that's on the band. Here they are in black and white, so you can pick out the call signs a little bit better. I mentioned that MAP65 keeps track of who you've already worked if you're doing it in a contest, and it'll put an asterisk next to the ones that you haven't worked yet. When I was playing this back, of course, I had an empty log, so I hadn't worked anybody, so it's telling me that I need to work all those people. Okay. All right. And the number next to them, by the way, is the frequency with the 144 left off. So here's 144, 103. Here's 144, 156. That's basically the whole EME subband for JT65 signals. Here is a messages window, just to give you a little bit more impression. And this perhaps is not even a particularly good choice, but you can, again, this is back from the time when I had only 2 Yagis. And this was during a contest, so there are lots of people calling CQ all the time. You can pick them out. There are people that are finishing contacts by sending Roger or 73. There are people that are calling somebody else or sending a signal report. They're all there. You can see who's working whom and line up your next QSO. I find, by the way, that with MAP65 running in a contest, I have a moderate station, only 4 Yagis on 2 meters. But I'm much better doing search and pounce in a contest because I can identify the people I haven't worked yet right here and just go call them. If I call CQ, I raise some stations, but I'm much better letting other people call CQ, and I'll go find them because I know where they are. A few more things about the interfacing between the software and the hardware. The receiver hardware, a soft rock, a FunCube dongle, the SDR-IQ, Alex's receiver here, the WSE converters, all of those are going to have different ways of interfacing to the system. You have either one polarization for these receivers at the left or both polarizations for these dual receivers over here at the right. They all need to interface to the computer in some way for setting the receiver frequency and a few other things like that you may want to be able to adjust from the software. You want to be able to do frequency control of the transmitter as well. You may or may not wish to use a front-end software program. So all those things are sort of summarized in this table. Look at that again on the printed version of this, and you'll get more details of what was in the table. So in summary, sort of about why you might want to be interested in trying MAP65, it's good for doing random EME on the VHF, UHF bands. No reason to leave out the US and Canadian bands, 222, 906, except nobody much is doing EME on those bands these days. The activity levels there don't really warrant using a wideband receiver like this. You don't need to use SCEDs. You don't need to use the logger, although many people do anyway, just to say hello to their friend and say something maybe after they've made a contact, but you don't need it at all. You can take advantage of an extremely good noise blanker. There's a very good one in MAP65. There's an even better one probably in LINRAD. And the reason, of course, is that noise blanking over a nearly 100 kilohertz band is much more effective than over a 2 kilohertz band. It distinguishes broadband noise from narrowband signals much more effectively. MAP65 is a very good way of monitoring the CW part of the band as well as the digital part. Although it's not going to decode the CW signals for you, it can let you identify them very quickly. And for 432 or 1296, where the digital activity is up sort of around 065, 070, 090, 080, somewhere in there, you can have that in the high part of the band and still display all the way down to 432.0 or 0.100, I mean, on 432, wherever you want to set it, so that you can see the low end of the band as well. I guess it is 432.0 there. And likewise on 1296. So you can sort of keep track on what's going on in CW as well as JT65. And it's, needless to say, it's a very nice contest operating aid. Just a few things then about details of operating the program. You're going to set it up and put in your station call sign and your grid locator and a few other details that are necessary to make interaction between the software and the hardware effective. You have some, you can select the input-output devices that are going to connect the software to the hardware, here you select a sound card input device, or you can select the network as the input device, and that means that you're going to be receiving the signals after they've passed through LINRAD or SDR-Radio. You can select an output device, the sound card device that's going to generate the audio and have that go into your transmitting system. Here's the astronomical data. It displays the usual azimuth and elevation for the moon. Likewise down here for the sun. It gives you your own self-Doppler. It gives you the Doppler, the mutual Doppler with the DX station that you're working in. It gives you the degradation relative to ideal conditions. It gives you the maximum non-reciprocal part of the path, which will be of interest, although if you're running a dual polarization system, you never worry about that, right? The non-reciprocal aspects of a path have to do with polarization mismatch, and that doesn't occur when you're using dual polarization, JT65. Here's my station control program, just for interest. When I said you basically click to track the moon, click on this button and press go down here, and the azimuth will and elevation will both track the moon. The frequency here is the frequency to which my single sideband transceiver is tuned. That's my transmit frequency. The receive frequency is determined by MAP65. It's the whole subband. This MAP65 writes a little file on the computer disk. The name of the file is asl.dat. It gives the azimuth and elevation of the moon and the sun, and the Doppler shift, and a few other bits of information like the transmit frequency, which is 115, 144, 115 here. All of that stuff is written to that little file so that some other program, in particular, in my case, this program, which is a very simple thing just written in a few hundred lines of Python, which reads this information and knows how to then interact with the tracking hardware so that I track the moon. On the MAP65 screen, there's a little button called Set Transmitter Frequency. It then reads this. This program then reads that number out of that file and sets the transmitter frequency so that I can work the next station that is on my list that I want to call. Some more setup features. Let's see if you on this menu item, you can adjust the IQ calibration. If you're not using LINRAD or SDR-Radio as an input, you will want the MAP65 software to adjust small errors in the amplitude and phase of the Q channel relative to the I channel for each one of the I and Q paths so as to properly attenuate the image frequency of the single sideband conversion. Likewise, you can find then you can apply that calibration once you've found it. You can find another important phase shift, which is basically a measurement of the different phase shift in your X channel and Y channel coming down from the two antennas to the back end. In principle, if you have exactly the same preamps and feed lines and your antennas are actually aligned with the elements at the same position, which is never true, by the way, then everything is in phase and you don't have to worry about it. But in practice, your feed lines are not going to be the same length, and so you're going to want to measure that phase offset down here, and you can do that in MAP65 and correct for it. Otherwise, you're going to have circular polarization mixed in with your linears if you haven't done that. If you're using the FunCube dongle, which works very nicely with MAP65, you have some settings that you can determine there. Click on that item, and it brings up this screen, which is not. It's actually a separate program, but is distributed on the website for the FunCube dongle, and you can set frequencies. You can set gains at different points along the path and so forth inside the FunCube. I strongly recommend, if you're going to use MAP65, read the blank manual, right? We write those things so that you can find out how to use the program, and I hope you will read it before you try to use the program. It's a big help. Now, I'm going to finish up in just a few minutes. I want to say a few things. Most of what I was talking about is based on my own experience using this program at 2 meters. But in some ways, as other people have already said today, there are good reasons why 432 and 1296 are the best EME bands in some ultimate sense. That's where the noise reaches a minimum, and there's nothing we can do about that. And so there are good reasons why EME conditions on those bands are even better than they are on 2 meters. You've got a much smaller system noise temperature if you've designed a good system. You've got much smaller antennas are big enough to do good EME. A 4 Yagi 2 meter system is a pretty big thing you've got to have up there on your tower. But 4 Yagis on 432 is enough, even with only a few hundred watts, to work a comparable station on CW, and it certainly is plenty to work even smaller stations on JT65. You can hear your own echoes with that sort of a system or this sort of a system, and so these are relatively modest systems that are enough with otherwise good equipment. And I remind you that MAP65 is great for stations that are going to use both digital and CW modes. So again, that's a good reason why, if you're on those higher bands, you might want to think about this. There hasn't been much use of dual polarization Yagis on 432, partly because it's hard to get all that stuff that you need to get in close to the driven element and fit everything in. And Justin Johnson is here, I think. I haven't met G0KSZ yet, but I know he's interested in making antennas for his Innov Antennas company that will do this, and I hope to have a chance. Justin, are you in here now? Yeah, okay. I look forward to talking with you later today or tomorrow about just that. But I hope that this will be an option that other people will find attractive to use on 432 in future. On 1296, of course, you don't have to worry about dual polarization. You can buy Alex's cheaper receiver, the IQ Plus single channel, because you're going to transmit right-hand circular and receive left-hand circular, and you don't need a dual channel system anyway. And that will work very nicely. Finally, I want to say just a few things about possible future developments in this kind of digital EME-related software area. There are good reasons why the protocol used in digital EME is based on timed transmissions of transmitting and receiving for fixed intervals. The 1 minute time transmission was obviously chosen somewhat arbitrarily, but it's about right, and it's fast enough that your QSOs don't take a long time. They take about 6 minutes because you need basically 6 transmissions to call CQ, have somebody call you, call him and send him a signal report, let him send you a signal report and a Roger, and so forth. That takes 5 or 6 transmissions. For contests, though, that means that the maximum number of QSOs you can make in an hour is about 10. And for many of us, most of the signals we're receiving during the contest, at least in the early stages, are way stronger than you need for JT65. You could work the guy on CW, after all. And in CW, you can work 20 or 30 stations an hour if you've got good operators on both ends. So for interest, I'm interested in looking at what about a system that, say, ran at twice the speed. Then you could work 20 QSOs per hour with 30-second sequences. The sensitivity would be about 3 dB less, but we've got much more than 3 dB in hand, typically, when a pair of 4 Yagi stations are working each other. There's a lot of extra signal around. So there's a mode called JT65 B2 and JT65 C2. Those are present as experimental modes in the recent versions of WSJT. They are not presently present in MAP65, but they could be, and I would put them there if I thought there was going to be any significant activity using those modes. They work well, and they do, in fact, work at the level just about 3 dB worse than the standard JT65B would do. The transmissions are 30 seconds instead of 1 minute. Some possible problems, particularly if we're doing this because we want to be able to work more stations in a EME contest. One of the advantages of using timed transmissions is that most people in Europe call CQ in the even-numbered minutes of a UTC hour, and in North America we use the odd-numbered minutes for responding, and vice versa. So that means that your local QRM is going to be transmitting the same time you are, so you don't have any local QRM. That's a big advantage. If some of us started using 30-second periods, we would lose that advantage because if somebody's using a 30-second transmission and you're receiving in the even minutes, he's going to be on at least half of that minute. So, that might mean that it would be a good idea if we set aside the low part of the 100 to 160 band, say 100 to 120 or something, used for 30-second QSOs. I don't know, but something like that might be advantageous. And I would hope that we could add this as a possible discussion topic. Thank you for the tomorrow afternoon. You'd also have to switch between modes. If you have 30-second QSOs and then 1-minute QSOs, you can't do both at once. So the program would have to know which one you're doing at a particular time. So there are some issues like that, but I don't think they will be insurmountable. I'd like to hear what other people have to think about them. But I see I've used up my time. Thank you all very much for your attention.
Okay.